previous session of MATLAB fundamentals, we were looking at the various types of plots that we can use in MATLAB, and in among them we actually had seen the plots such as line plots, the bar plots. Then we checked how to plot the staircase. Then we had one important error related bar called as error bar plot. Later on, we actually had seen another type of plot. It is called as the polar plot. Okay, now uh, in today's session, we are going to begin with what we call as the stem plot. Okay, so the plot number, this will be plot number 6, and it is called as the stem plot. Okay, so now I will directly go to the MATLAB window and we'll check how to plot a stem plot. Okay, so first we generate the required axis for this, right? So let's say we start from creating a variable called x, and I want to have the values starting from 0 with a spacing of 0.1, say up to maybe 5. Okay, and then I create the function, that is say y is equal to, this is maybe 0.85 into, I want to write a sine function, sine of x, every term in x I want to raise it to the power 2. Okay, x 2. Again, I want to multiply every answer here, so dot star. Let's say I want to have a decaying exponential here, so this is e to the power, that is exponential of decaying will be minus x. Let's create this. So 0.85 times something into this. Okay, I got plot. So in order to get a stem plot, the function is a stem itself. All right, so stem of, mention what you want along x-axis, that is x comma y. I just press enter so that we can see the plot, right? You can see that discrete plot is coming up here, and if at all you want to see the discretized plot instead of continuous plot, you can go for a stem. All right, so at the same time, instead of stem, if I call a normal plot over here, so I am expecting the simple plot, right, which you can see here, right? This will be the simple plot. If you call a normal plot, it's going to be like this. So instead of that, you want to see the discretized values, every discrete value that it takes, right? If you want to see that, then the option here is to use what is called as the stem plot. Okay, so that is the use of the plot called as the stem plot. Next, now we go for another type of plot, and this kind of plot, this is plot number 7, is called as the scatter, S-C-A-T-T-E-R, scatter plot. So in case of a scatter plot, we try to scatter the function, right? Whatever function we generate, we want to plot it all over, right? The various values of its variables. For example, let us consider the old data which we had used for analyzing it, for creating a table and analyzing the table. For example, let's do this. Clear. Let's say I want to load something from what we already have, say load patients. So we know that there is a file called patients.dat. You are reading something from that, and let me uh, read the specific values, like I think H is capital over there, or I'll simply load patients itself. Let's see what it comes. You can see that a lot of the workspace gets filled with the data that is present inside the patients, correct? And now if you want to plot a scatter plot, then the option is directly call the function called scatter. So scatter, and I have to specify what I need to plot versus what. So I can call, say, height as one variable versus the weight. Let's see what happens. So I am able to see, right, the various values of height that the patient data has. You can see that somewhere around 60 is the minimum data, right, of height. And anyway, let me make it more clear. So let me give the x and y values so that we can trace what is being plotted along which axis. So I can see that the x axis is the I think the height is plotted along the x axis. So I'll give x label height and y label weight. So now we can trace what exactly has been plotted over here, right? So you can see that the height actually varies from minimum value 60 and it goes all the way till 72. At the same time, the weight of the patients here is minimum 110 and goes till 200 and I think 205 or something close to that. So let's see, this is the highest one. So 202, right? So it's a scatter plot which shows you a clear which gives you a clear idea about uh, how the weight versus height has been scattered among your data set, right? So we can get a clear-cut idea using a plot like this. So the scatter plot is useful to have the complete scattered idea about our data set. All right, so that plot is called as a scatter plot. Then we go for another type of plot, and this is plot number 8. The basic plot number 8 is called as the pie. So it's a normal pie chart. Okay, so this is, we can call it as a pie chart or pie plot. All right, so now we'll see how to plot this. First, let's clear the screen, and let me create a variable which holds the data required for this. So uh, I want to have, say, x as my variable. I'll start with x. So x is equal to, let's create one, say 2 and 3, let's see. Okay, only I create a variable called x, and in this I want to plot three different data on a pie with the ratio 1 is to 2 is to 3, right? The angles will be of the same one. The 360 will be divided into 6 parts, out of which one will go to the first data, 2 parts will go to the second, and the remaining 3 will go to that. Okay, so this is what is expected. Now I'll go for a figure, and then I will call. Now you can see nothing is plotted in this new figure which has been created just now, but I can call pi of this variable x which we have created. So you can see that the figure now, right, is divided. Actually, the figure got updated with the pie chart. Again, I want to give the details of this pie chart. So what is the detail that we are going to get? We can actually give the detail about which color is for say which color for. I can give a detail in terms of label, right? Let's create the label now. So label, and in the label we know that I have to specify as, see, since we have three different labels to be given for three different colors, right? So all I can do now is I can create a cell. Okay, I can give a labels. First let me create a labels first. So labels are, in the sense, I have to create three different names to be given. So let me give, this is say product 1. Then, so since it is a cell array, I have to specify inside the single quotes, because everything will be considered as a, it's a cell array. Each cell consists of characters in the form of array. All right, so I just have to mention this is product 1, then product number 2, and then product number 3. So let's say that each product is what we are trying to plot over there. So this creates simply a variable called labels, and let me generate the legend now. So legend, so your legend gives you the details. I will call the labels. I have to use the labels, and now you see legends can specify where you want, right? So one option is a location. If you remember, previously we had used the same option, location, and we called northwest, right, in one of the graphs. But now I don't want to get it the northwest location. Say I want to get the legend just below the graph. So exactly below means it is uh, the south. Okay, so in order to specify south, we will mention south side. All right, followed by, let me say, what is the orientation? In the sense, do you want it to be horizontal or vertical? I have two options. So I will specify the orientation in which I want the legend to be present. Say I want it horizontal. Okay, now I press enter. Uh, just a second, I think I made a mistake in typing that. Location. Oh, you can, okay, it should be south, my mistake. I think outside is there. Yeah, south, southwest. Oh, it should be south outside. My mistake. Sorry. Instead of that, I simply told south side. I want outside the graph. So south outside. Let's see. Okay, oh, my mistake. Sorry, typing error. Horizontal. I think that works. Just see. Now we have this graph, and you can see that the graph is updated, right? Below this, I can see that the product 1, product 2, product 3 with different colors, right? Exact colors are being shown over there. If I don't say outside, this graph will come inside this circle, right? Which doesn't look good for us. So you can see that the options we have, it's actually shown when I made a typing error. You can see what are the options you have. Either you can simply say north, south, east, west, or northeast, etc. Otherwise, you want to have it outside, means north outside, south outside, etc. Right? I have to specify in this. Okay. So if you don't want to specify where exactly you want and the best suitable place, let the MATLAB decide. If you want to do that, then the best is the option. Otherwise, best outside. You can do that. Right? It looks where is the best suitable place, and it's going to put the legend over there. Okay. Right. So now you can see clearly that the figure which we created for the pie chart, right? It plots a pie chart, plus you can actually generate the required legend as shown. All right. In the next plot option, we go for a very special type of plot. This plot is called as, this is the plot number 9. This is called as the bubble chart. It's a bubble chart. So this particular chart tries to define the bubble coordinates as the x versus y, and there will be a size, another variable that specifies the size of the bubble. In a sense, every location of x comma y that you define, right, will correspond to uh, a bubble, and the bubble size will be determined by uh, there is another third variable which is called as the bubble sorry, the size variable. I have to create 3 variables now. So let's go to the MATLAB window first, and then let us try to create the required variables first. Right now, first let's create the required variables. Right, I will create, say, x is equal to, say, 1 till maybe 30. Right, it creates an array of size 30. We're starting from 1 to 30. And y, I want to define y is equal to, let's create a random variable. So it's a random. How many I want that to be one row, 30 columns. Let's create this. And I create another, say, variable called size. Sz is equal to, here I create another random variable, that's random, once again 1 to 30. All right, so I'm creating randomly this now. Then in order to get a bubble plot, I'll go for a function called bubble chart. It's a bubble chart. Specify what you want, in the sense what has to be plotted along x-axis, what should be along y-axis, and what should be the size of the bubbles that you define, right? That is sz. All right, now you see, just let me check, Bubblechat. No, the spelling is correct. uh, Let I think my particular version is not supporting. All right, just a second. Let me check. Yeah, sorry. Okay, it's not there. But anyway, I'll show you one diagram. When we call this, what actually comes up. Okay, let me just show you the plot, which actually I have saved it in the form of the screenshot. All right, I have saved that. I will open that and I'll show you. Okay, so the bubble chart which I'm talking about now is going to look like this. Okay, so this is a bubble chart. So once you run that part of the code, right, you will be able to see a chart like this. So wherever the circles are defined, you can see the circles, right? So it's a bubble, and the size of the bubble depends upon, right, what the size we have defined and at what location. The center of the bubble will be defined by the locations X and Y. All right, then let's move ahead. Then we have a another type of plot. This is called as quiver plot. I'll just show you that. This is the plot number 10. It's actually it's a vector plot. So in order to have a vector plot, we have to create a separative function. Okay, so that function is called as QUIVER, quiver. Okay, it's a quiver function. But anyway, let me first create the required variables in the MATLAB window. Okay. Okay, so first let's load something. Uh, so let me load. There is a particular file by the name wind. Okay, you can see u, v, w, x, y, z. All those variables are present over there. Okay, and let me take x. Okay, I'll create a, okay, let me create a bigger value x. So you can see that this is, every variable here is actually a three-dimensional signal, u, v, w, x, y, z, out of which I want to extract only two dimensions, right? X starting from 11 till 22, comma y-axis number of columns also 11 till 22, and the first dimension. Okay, I just want this. So x from 11 to 22, y from 11 to 22, in the sense the second coordinate, and only the first page of that. I'll just read this. Okay, this is what I want to read as the first one. So you can see that the capital X has to be created now. Similarly, I create a y is equal to small y of, I'll read this. Then I will also create the u and v, x, y. Then I create a u is equal to small u of similar one, and v is equal to the small v which is present in the file of this. Okay, so I created the required values now. So the vector plot shows you the direction, right? At what position, what is the direction I will be able to see, right? For which I have to call the function QIVER, quiver, of what is x, what is along y, and then I need to tell the right coordinates of in terms of u and v. So I'll tell u versus v. So this actually shows you what is the size of the wind, right? How much wind. It's actually the data which I loaded was related to a project which measured the wind direction at different positions, correct? So you can see that the wind is whenever where you see the size of the wind as a higher value, bigger value, correct? That means there is more wind at that location, and the smaller winds and different orientations of that those arrow marks indicate the direction and the magnitude of wind. So we can obtain these kind of plots, right? They are very special plots, right? If we bring something like this in our some reports or something, that gets a lot of weightage to that, right? So always this kind of plots are important, and it can be easily plotted if we know, right, the appropriate usage of MATLAB according to this. Okay. In addition to this, then we have another very important plot. So that particular plot is called as the compass plot. This is plot number 11. It is compass plot. Okay, so now let's see how to use the compass plot. The difference between this plot and the previous plot, that previous plot takes care of the position, right? The vector plot takes care of which position and how much, right? In case of the current plot, that is a compass plot, we know that the compass is always centered at a fixed point, and its position will keep changing as per the direction, right? So according to that, very similarly, we try to plot a compass plot here, where you are actually trying to draw various arrows. The length of one end of the arrow will be fixed to something like an origin, and other the heads of arrows that you are going to plot will change their positions, right, indicating the various directions. All right, so this is what is the use of the compass plot. So let's clear everything first, then we'll create the variables required for that. Let's assume that I create the first variable as u is equal to, let me write a few values, say 5, 3, -6, say -4, and 2. So this is u, and then I call v is equal to, I'll create another set of values over here, that is 1, 3, -5, 7, and say 9. All right, then in order to create the plot using this, I have to specify using the function called this compass, compass. I have to tell what is my first variable u, second variable v. So you can see that it creates the variables like it uses all the variables and plots, right? So it actually calculates the tan inverse of v by u, and that will be the angle with respect to 0 line, and the magnitude is root of 5 square plus 1 square, right? So that's the length of the first arrow. Like that, you can see that the highest arrow comes for 5 and 6. That's the third one. You can see this is here, right? And you also have the 7 comma 4 minus 4 comma 7, that is here, and 2 comma 9, that is over here. Okay, so like that you can try to plot, and this kind of plots are also very important and for data analytic purposes, and we can see that we can plot those using this particular type of function. All right, so I'll just run that once again. So let's see now. So the lengths of various arrows are different, and their directions are also different. So the directions are identified by tan inverse of the v by u value of each of the for each index, and the that's about the angle, and the magnitude is determined by the root of every corresponding index. Like 5 and 1 means root of 5 square plus 1 square, and if you want to go to the third one, it's a root of 5 square plus 6 square, and so on. So like that, we have the various options, right, to measure the lengths of each one of them. Okay, so this graph is called as the polar plot, right? Now, among these graphs, right, we need to know what are the various options we get. Okay, so the various options that we have in terms of these plots are called as the formatting and the annotation. Okay, so we'll move on to the next topic. This is called as formatting and annotation. All right, now let us try to first plot a graph, and then we'll see how to add the title, axis labels, etc. So that comes as the first part of our formatting and annotation. All right, first now let me create the variable. So I create the x-axis by using another function that is called as line space. Okay, it's there is no e over there, sorry, it's a line, linspace. Line space is the one which divides the interval in a linear fashion, and you can actually specify how many numbers you want. For example, I want to divide minus 2 pi to plus 2 pi. This is my interval, and I want to divide this linearly equally 100 pieces. So you can simply write, instead of starting from minus 2 pi till plus 2 pi with the specific value to be calculated. Now I don't know what is the interval, right? But I can space that I need 100 intervals. All right. So that's how I can define this. Now interval will be calculated automatically by itself. So I don't have to specify what is the interval. Then let me create two variables now to plot. So y1 is equal to, this is a maybe simple function I'll plot. One is a sine function, this is sine x, and I'll also create another one that is y2 is equal to cos x. All right, then I'll go for a plot. I want to have the normal plot. So I want to plot two graphs on the same plot. So I have to specify x comma y1, and I also want to plot x versus y2. All right. So now you can see that both the plots come up in the same window or the same figure. Right. Now, next what I want to do is, let me say that I want to specify its x-axis and the y-axis. Also, I want to generate the title, let us assume. Okay, so I will specify the title first. So title, let's say it's a line plot of sine and cosine between, say I want to specify, see there is one option here that is say -2. There is no direct symbol typing possible for pi, but if you want to print the value pi as it is, like the symbol for pi, then I have an option that you just write \pi. MATLAB will detect a \pi as it has to print the pi value as it is. So it will print -2 with the symbol pi. Okay, I'll show you that. -2 pi, and I'll also write +2 \pi. Okay, I'll just create this now. You see what happens, right? I can see that, see the the pi value has been printed over there. Okay, -2 pi and 2 pi, right? So that's how the pi symbol can be printed easily over here, right? This technique we were not knowing earlier. Now you can use the for any symbol that is standard and you want to print over there, you can use like this. Okay, that's one thing. And after I add a title to this, let me go for the axis labels, right? Already we have used this, but let's recall that once again. So x, if I want to go for x label, again I will specify the x label now as it's actually the limit, complete limit, right? So I'll specify x label to be say -2 pi. I just want to print a less than. I want to print say x-axis is x, once again less than, it's a +2 say pi. Okay, I just want to print this. Now you can see that that also should come up here at the bottom, right? -2 pi less than x less than 2 pi. So that's what I try to plot along the x-axis, right? And you can add a normal y label, and you can specify the uh, sine and cosine values, right? So now the figure looks complete with the complete details what we are trying to plot. In addition to that, we know that we can use what is called as a legend, right? So when I say a legend, it actually whatever I specify as the first one, that goes for the first plot. Okay, so for example, legend. So when I call the legend, it has to be, if at all you want to plot multiple uh, details of various graphs present over there, then actually the legend becomes a function, and you will specify what is a label one. I want multiple labels. I can specify multiple labels inside the same graph by using what is called as by making an array of cells. So I just have to mention inside the flower bracket that what is your first function. In the sense, this is, you can see y1 will be plotted first, so I have to give the details of y1 itself first. If I give the details of y2 first, it will print the details of y2 as the details of y1. So that is what is the problem here, right? So should be very careful when we do that. All right, so look at this. I have to specify y is equal to the first function I called here to plot is y1. y1 is a sine function. So I'll simply write y is equal to sine of x. Now you see it is actually a text, so it will not consider the mathematics behind that. All right, simply it will do this. And the second one I want to plot is y is equal to, say, cos x. Okay, so this is the cell array we create, and then I'll specify even the location. Anyway, we are very familiar with the location now, so I'll add location as say I want to print in the southwest. All right, so let's press enter. Now if you see this, the what you call as the legend has been added at the southwest position. It says that the first plot, which is plotted in the blue color, it automatically identifies what has been plotted first and adds the first legend to that, that is y equal to sin x. And the second plot is actually red color and automatically identifies that the second plot is in red color, and the second legend which we had typed inside the legend function is y equal to cos x. It assigns that and prints over here. So what we see here, right, itself is the legend corresponding to this graph. Okay, so that's how we add the legend to the function. All right, and in the next formatting trick, what we do here is we'll specify what I want along the x and y axis. Okay, that's what I'm going to call as a specifying the limits of x and y axis. So formatting and annotation, in which first we added the I'll just type what we had done so far. First we looked at the x label, y label, then we looked at the title of the graph, and then the legend. All right, and now our intention is to learn how to specify the axis limits. So if I want to specify what limit should be applied for the axis, then this is the best suitable technique. Okay, now let's go to the MATLAB screen and we'll check out how to specify this. Okay, so first let's clear the command window. Now let me create the x and y variables first. So I use x is equal to, it's a linear spacing I want to create between, say, -10 to +10, and let me assume that I want to create 250 points. Okay, next I want to create the function y is equal to, say, this is 2.5 into sine of 4 sine 4x, say, dot divided by the exponential x. So let's try to create a function like this. Okay, y is created. Now I'll go for a plot, okay, of x comma y. So now if you see the plot, it actually has plotted, right, the graph with, you can see the x-axis varies from -10 to +10, and the y-axis varies from -5 into +3 into 10 to the 4. Okay, it's -5 to some number. But now you see, I don't want this limits for x and y. I want to visualize the graph in a different fashion, right? Let us assume I don't want to see the graph, right, between maybe See, I just want to see the plot in a specific manner, something like this. Something like, okay, so let me go for the specification of the limits along x-axis, that is x-lim. X-lim is the limit for x-axis. You specify from where to where you want to see. Maybe I can write 0, starting from 0 to 10. Let's see what happens when I plot this. So now you can see that the same graph is actually being plotted with the limits 0 to 10 along x-axis. Okay, also I can specify the y limits in the following way. That is, I'll specify the y-axis limit using y-lim, right? Specify this value like minus 0.4 till plus 0.8 maybe. Okay, let's see whether this changes. Now I pressed enter, so that you can see that y-axis actually changed. It's actually plotting only between minus 0.4 to plus 0.8, even if your signal is extending beyond that limit, right? So that's how you can specify x and y limits which you want to see. Okay, now after doing this, if I want to go back, right, say I want to reset my limits. So how to do that? You can simply call xlim space. After space, you specify I want auto. Auto indicates it performs the original. You can see minus 10 to plus 10 was our original case. It actually plots that. Again, y as actually has been already limited. I'll make it auto once again. So y lim auto. Now you see even the y values, right, are actually modified, right? It's actually applicable even for z-lim, right? I can make auto, but in this graph I don't see any difference because this is a two-dimensional plot. But when we go for a three-dimensional plot, definitely there will be some type of difference when I reset the z limit by using the z-lim space auto.